All right, welcome back, everybody. This is episode 7 in my Elisity Cognitive Trust video series. And in this episode, we're going to be focusing on the 4 stages of the MITRE ATT&CK matrix for enterprises that Elisity is able to assist in when it comes to mitigation and remediation. There's many methods that hackers use today to conduct cyber attacks, and oftentimes in converged or semi-converged IT and OT networks, there's little that can be done to increase endpoint security because you're at the mercy of the distributors for software and firmware patches. And these integrated devices have known vulnerabilities that are easily discovered and exploitable once an attacker has gained access to your network. This is why the castle and moat approach doesn't really work today. And the best way to mitigate these attacks is through identity-based microsegmentation. So today I have brought on my colleague, Taylor Colwell, who's going to give a little demo and a real world scenario and show exactly what Elisity is able to do to solve for these problems in the industry today. Taylor?
Thanks for having me back, Dana. It's a pleasure to be here.
Absolutely.
So like you said, Dana, we're focusing on 4 stages of the MITRE ATT&CK matrix for enterprises, those being reconnaissance, initial access, lateral movement, and post-breach impact. So at each of these 4 stages, we're taking mitigation and remediation steps. Starting with reconnaissance, we're going to limit network visibility and access through microsegmentation. We're going to limit initial access to these devices by preventing initial footholds within the network and locking down ports and protocols to these devices to prevent attackers from establishing these initial footholds. For lateral movement, we're going to mitigate additional risk if an initial foothold is established, greatly reducing the blast radius and risk vectors by limiting this compromised device ability to reach other devices on the network. And finally, we have remediation steps to reduce negative impacts of breaches in network security with our ability to quickly deploy policy to endpoints on the network without knowing where they are or how they're connected. So in this case, an attacker has gained access to a workstation on the IT/OT network and installed scanning tools on the device. This bad actor could have accessed this workstation in a number of ways, leveraging insecure remote access solutions, or by phishing for credentials and exploiting privileges, or by abusing methods of authentication. For our case, how they gained access to this device doesn't really matter. They have gained access to this workstation. They've installed Nmap, Nessus, vulnerability scanner, and this user seeks to disrupt operations by first discovering and then gaining access to industrial devices and essentially bricking them with malware, for monetary gain. So what I want to do now is jump onto this workstation and we're going to do a network scan of the OT network. So in this case, we're going to do a Zenmap scan of the network with no policies in place. So there's no segmentation in place from Elisity here. So we're running the scan of the entire operational technology subnet where all of our PLCs and SCADA controllers are operated. And we're going to see what we return here. Okay, guys, so our Nmap scan of the OT network is completed. We've discovered 4 hosts, and 3 of these have some ports open, particularly this 10.100.1.88. So here you can see we have open visibility into all the devices on this OT network and all the open ports. And we have the ability to scan for vulnerabilities on these devices from this workstation. So let's go ahead and do that. So we've completed our OT network scan, and here are those same hosts that we just found on Nmap. And here we can see we have some vulnerabilities present, particularly on .1.88 here. This is a SCADA server that we found on the network. We have several PLCs and SCADA servers. This is our primary SCADA server. And here we can see we have 3 critical vulnerabilities. So let's check these out. So here we found on this server, we have the Apache Log4j vulnerability that's very well known in the industry.
Yeah, Taylor, that Log4j vulnerability, since being discovered sometime in 2021, has been a huge problem for the industry. So many organizations across all sorts of different verticals have been brought to their knees because of that particular vulnerability. And actually, the Cybersecurity and Infrastructure Security Agency called CISA, they wrote a report, and they say in that report, and this is a direct quote, that OT ICS devices, if segmented appropriately from the IT environment, do not face the internet and, as such, have a smaller attack surface to this vulnerability. Exploitation of IT devices may affect OT ICS devices if there is insufficient network segmentation that prevents lateral movement. A pretty powerful and accurate statement. And Elicity, we have the solution to provide this identity-based microsegmentation across your entire network.
Exactly. We can leverage principles of least functionality to make these connections between devices much more secure. There are devices on your network that may have this vulnerability and you're unaware. And when you have hundreds or thousands of devices on your network, it's imperative that you implement identity-based microsegmentation to lock down these devices, because it's nearly impossible to find every vulnerability on every device when you're at the
Yeah.
mercy of these distributors.
Yeah, exactly. I know there's a story. I was talking to a process control network expert, and what he told me was that he was on a project where the organization was trying to lock down all sorts of unused but open services on their OT network across SCADA servers, across PLCs, and different nodes in the OT network. And to solve for this, they had to go to every single device, an application, and manually lock it down. And that's not a very flexible or easy way to implement any type of security. You need something that can do this across the board, simply, quickly, using only identity. And that's the proper approach to this. And it allows you to also create very granular policies so that you can allow the access from certain environments or certain users or certain devices or certain applications, but not others. So you can be either super granular with these policies or create a broad policy. We support both ways, and it's up to the end user how they want to implement it.
That's a great point, Dana. Let's take a look at how we can do that with Elicity and how quick and easy it is to eliminate these vulnerabilities using identity-based policies. So here we are in Cloud Control Center. Let's move over to our device dashboard and identify this SCADA server in question with this vulnerability. So here we can see our IP address 10.100.1.88. Here we see we have a SCADA server in zone 2.5. And if we look at all of the data that we've gleaned about this device, we can see some of the criteria that we're able to match on for policy. In this case, device type SCADA server, device class industry. We can see this device is a member of a policy group, OT SCADA servers. Let's move over to our policy matrix and let's look at implementing some policies for this device. So in our policy matrix, this is the policy group that we had just identified for this device, OT SCADA servers. Let's filter based on our destination policy group. So here we can see all of our source policy groups, and we can see we have not a lot of policies implemented currently for this SCADA server. We want to implement policies that limit traffic to this device from other network devices. And we want to limit traffic between our workstation to our SCADA server here. That way, this workstation that has these vulnerability scanners can no longer see these vulnerabilities on the device because of our granular policy in place. Let's start there. Because our workstation is identity-based, our source policy group is based on our Active Directory group operators. So any user that logs in to this workstation as an operator will fall into this policy group. The machine will fall into this policy group. We could also make a policy based on the workstation, regardless of what user is signed in.
Yeah, my understanding is that not all OT environments will have different users logging into the same workstation. They might have many users using the same user ID on that workstation. So we have to figure out a way to do identity based off the device itself and not the user, right? So we have that functionality.
So if we click on this intersection on the policy matrix, here we can see our source and destination policy groups are pre-filled. We have a policy group OT operators. We can see we're matching on a user, Josh Ritter, from Active Directory. And for our destination, we can see we're matching to two assets, one of those being our SCADA server in zone 2.5. Let's fill out some security profile rules. So typically between a SCADA master and a SCADA server, there's a set of policies that we need for this device to function. So again, back to those principles of least functionality, we're going to implement a policy here to only enable protocols that are required for these two devices to function as intended. And we're going to close down all other traffic between these devices. So we'll select the layer 3, layer 4 protocol. We're going to select first Modbus traffic, TCP. Down here in actions, we'll click allow. Let's add another security rule. Another layer 3, layer 4 protocol, this time DNP3. We're going to allow that. Now we need to create a custom TCP rule. So we'll go back to layer 3, layer 4. We'll select custom TCP rule. And this is another common protocol that is required for these devices to function. It uses destination port 102.
And Taylor, when you mention devices, you're actually talking about the device that Josh Ritter, that particular OT operator that logged in, is acting on. But he could have logged into any device or any workstation in a network and he would get the same policy. The policy would follow his identity, correct?
He could log into any of the workstations and this policy would be applied to that workstation because of his identity. And again, going back to our previous comments, this policy could be based on the device identity as well. It doesn't have to be user identity. We're also going to allow ICMP traffic here. So we'll select layer 3, layer 4 protocol, and we'll click all ICMP. Down here, we'll click allow. And we want to deny all other traffic. So we'll add one more security rule here. And this is a granular policy. This is an example of one of our more granular policies. Select all traffic, and we'll select deny. And here we'll click deploy. And within seconds, this policy will be implemented on all policy enforcement nodes where a device that identifies to these policy groups is attached.
Got it.
Here we can see our policy is alive and active. So we've deployed a granular policy from OT operators to OT SCADA servers on our network. But we want to limit lateral movement and visibility into the rest of our network from our source group OT operators. So our operator is logged into our workstation. So we'll simply shift click from our source group OT operators to every other policy group that we want to deny traffic to.
So here you're just basically multi-selecting all the policy groups you want denied access to when it comes to that other source group, right?
Exactly. With one click, we can eliminate access to a variety of other devices on our network.
Nice.
So up at the top, we'll click Add Security Profile, and we will select Security Profile, Rule, Deny All, and we'll click Deploy. And here we can see as our page refreshes, we've successfully deployed deny all policies to, a couple of dozen other policy groups that quickly.
Yeah, that's beautiful.
So, yeah, in seconds, we've limited lateral movement dramatically. The maturity of your network design, whether you're implementing Purdue strictly or you have a completely flat network, we don't care. Our policy works either way, and we can microsegment your network regardless of your network design.
Yeah, so completely agnostic of your network topology. That's pretty powerful. So you don't have to go in there and change any VLANs. You don't have to go redesign your network. No change of your cabling or hardware. It's just simply layers on top.
Exactly. So now let's test our granular policy from OT operators to OT SCADA servers. So we'll move back over to our compromised workstation. And let's run another vulnerability scan on our primary SCADA server. So I already have the scan set up. Let's just go ahead and run another scan on this device. So we can see by scanning the OT network again, after implementing our set of policies, that we've drastically reduced the number of vulnerabilities that we're able to see on this network. By denying traffic to devices we don't need access to and implementing least privilege policies to other devices, we can no longer see those critical vulnerabilities that we saw on our first scan. And we're actually unable to scan our SCADA servers entirely because we're blocking certain protocols and ports that Nessus requires to do a successful scan on those endpoints. However, if we move over to our Nmap scan, we can see these devices still, but we can only see the ports that we're allowing through policy. So where previously we would see more open ports, because our policy is blocking those ports, when we do the scan, those ports don't show up anymore. And the key takeaway here is This access directly reflects the policies that we've just implemented. And by blocking these protocols, we're essentially eliminating these vulnerabilities.
Okay, so that means you could apply this across hundreds, thousands, tens of thousands of assets in your network in seconds or minutes, right? This is pretty powerful. You don't have to go to all of these devices or assets and do anything manually. It's all done from the network edge.
Yeah, Dana, while one approach is to eliminate the vulnerability at the asset level, it's impossible to do that for every asset. And, this could have been ground zero for this vulnerability. Maybe this vulnerability wasn't well known yet or well discovered.
Yeah, true.
So now let's talk about impact response. So traditionally, in the case of a security incident, the organization is unaware that an incident has taken place until it's too late. So at this point, for the organization, response is less about damage control and more about cleanup and remediation because damage has already been done. So in the case of a security incident where you have the opportunity to limit lateral movement, to control the blast radius, the ability to quickly deploy policy and respond to an incident with policy is critical. So there's a number of ways that we could isolate this user who's been compromised. But the way that I'd like to demonstrate is creating a new policy group for compromised users and assets. So we'll go to policy groups. I'm going to click add policy group, and we'll name this policy group compromised assets. What we want to do now is match on our user ID, Josh. And again, you could do this with any number of match criteria for any device or any user. This is just one small example. So we've matched to Josh, our compromised user. We'll click deploy for this policy group. And now this policy group is referenceable on our policy matrix. So what we want to do next, we want to deny Josh service to the entire network. So we can deploy this policy with one click. We just find the intersection between our source policy group, compromised assets, and our destination policy group, any, and we can quickly isolate this user wherever they're located on whatever device they're located on in the network. We'll simply deploy a deny all security profile, and we'll see in real time this device's network access will be limited and blocked to every asset on the network.
Yeah, Taylor, every time I show my customers this particular functionality where we can isolate compromised assets really quickly, it blows their mind because they realize that they don't have to run around the network to figure out where is this device or this user, has it moved, and then physically unplug it or do something on a firewall to block it. It's just a lot of complexity and time wasted. They can just jump in here, identify the device or the user or the application, and push that policy, and immediately it's off the network. It's really mind-blowing. Taylor, fantastic demo today. I love how applicable it was to the real world. And while this demonstration today was focused on OT networks, the same concepts and functionalities are equally applicable to really any type of network, IT, medical, manufacturing, it doesn't matter. Again, our solution is agnostic to that. Elisity is really just hyper-focused on time to value so that you can rest assured that getting the solution enabled in your environment is really straightforward, and the care and feeding of it over time is also quite minimal. I want to thank everybody for listening today. We'll see you in the next one.